All right, in this video, I'm going to be solving this problem on direct calculus differentiation using two different approaches. First, I'm going to solve it using algebraic approach where I'll show you the steps step by step of arriving at a solution. And next, I'm also going to solve the same problem using the geometric approach where I'm going to be deploying GeoGebra. So what you see on my screen right now is GeoGebra. We use GeoGebra to solve it geometrically and relate the answer to solutions to see if what we arrive using the algebraic approach is the same thing as what geometry is going to, we get using GeoGebra. Right. So now let's go ahead and solve the question. The question says if f is a function from R into R and is defined by f of x equal to e to the power of negative cos x sine x for all x in R, then f prime of 0 is what? So if you look closely, you will discover, you will notice that the given function f of x is a function of products of two other functions. So meaning that we are going to be using the product rule that states that if y is equal to uv, where u and v are both functions of x, then the y dx, which can be written as y prime, is equal to u v prime, that is u the v dx plus v du dx, u v prime plus v u prime. So this is just a recapitulation. So here's the formula which we are going to use to solve this particular question. Now let's dive into the solution without wasting of time. So given the function f of x, let me recall the function again. F of x equal to exponential minus cos x times sine x. In this case, I'll take u as the first function, exponential minus cos x, and represent v as sine x. Next, by the rule states that we are meant to differentiate u and also differentiate v. Then substitute the derivatives and the initial functions back into the formula. So meaning we have to differentiate u prime, which is the u dx, that's equal to, now pay close attention to this function, e raised to power negative cos x. So this function on its own, it's a chain rule, or it's a function of function rather. So to solve this function, we are going to deploy the chain rule to solve this function. And looking at it again, cos itself is another function of function, meaning I'm going to be using a function of function of function to differentiate this function. So let's quickly recall how to differentiate uh, exponential function. So given that y is equal to exponential, let's say kx, to differentiate this function, what we do is simply differentiate the power, the exponent kx. And when you differentiate the exponent kx, that will be k, then multiplied by the whole function itself. So the derivative of exponential kx is equal to k exponential kx. Now, in that sense, we are going to differentiate this function going by that rule. So here I'm differentiating exponential minus cos x. Now, taking out minus cos x, the derivative of cos x is negative sine x. So the derivative of negative cos x will now be equal to negative sine x. All right, times the function itself. So using this rule times the function itself. e to the power of negative cos x. So that is derivative of u. Then the derivative of v with respect to x should be equal to cos x. This is a direct differentiation. When you differentiate sine x, you get cos x. So now, having done this, we are going back to introduce or to substitute each of these derivatives and their initials back into the function. So therefore, f of x, or rather f prime of x, is equal to u. U is e to the negative power e raised to power negative cos x times v prime, that is cos x plus v, which is sine x, times u prime. So here is a minus times minus is plus. So u prime is times sine x times sine x e to the negative e to the power of negative cos x. Okay, so let's simplify this further before we do the substitution. So here is equal to, now by inspection you see that there is an e here, e to the power of negative x, e to the power of negative cos x, and e to the power of negative cos x common to both sides of the expression. So we're going to factor out that e to the power of negative cos x times cos x plus sine squared x. All right, so here is the final derivative of f, the first derivative of f of x. Now at x equal to 0, so f of x at x equal to 0 will be equal to e to the negative power of cos 0 times cos 0 plus sine squared 0. Here is equal to e, of course, cos 0 is 1, so this is e to the negative power of 1. Cos 0 here is 1, sine 0 here is 0. 1 plus 0 is 1. And 1 times e to the negative power of 1 is t e to the power of negative 1 rather. So here is a f prime of 0. We've arrived at our answer. Very short, simple, and precise. So now let's go and compare this answer with the answer we're going to get when we differentiate using GeoGebra. Again, let's key in the function here. So f of x is equal to e to the power of negative cos x times sine x times sine x. Okay, so that is the function e to the power of negative cos x times sine x, and here is the graph you see on the screen. So you can see the graph is very close to being like a sinusoidal graph because it's a combination of the sine function, the cosine function, and the exponential function. Okay, let's take the first derivative of this function, f prime of x is equal to that. So the color, the brown color, is the derivative of the ash color. That is the derivative of the function, which is f of x. Then to conclude our solution, take the first derivative of this function at x equals 0. And the answer is 0.37. Would that be the right answer? Here, we arrive at negative exponential of the power of negative 1 is The question now is exponential raised to power minus 1 is the same thing as 0.37. Of course, you can confirm. Let's find out what it is. Minus 1. Wow, so that is equal, meaning that the derivative of the given function f of x equal to exponential to the power of minus negative cos x and x is equal to e to the power of negative 1. So you've seen the solution algebraically, you've seen the solution geometrically. So thank you for watching this video. For questions, feel free to post your questions in the comment section. Like this video and subscribe to this YouTube channel for more videos of this nature. Remain blessed.